Right now, in Rome, engineers are trying to rebuild part of the Colosseum floor. Not the whole structure. Not the walls. Not the arches. Just the wooden floor that used to cover the arena. And they are struggling. The project has been delayed for years. The costs have exploded. The engineering challenges have turned out to be far more complex than anyone expected. And this is just the floor. Now ask yourself this: if the greatest engineers, the greatest construction companies, and the greatest technology of the 21st century are struggling to rebuild a single floor, what would happen if we tried to rebuild the entire Colosseum from scratch? The answer is that we cannot. Not because we lack money. Not because we lack workers. But because the Romans built the Colosseum using techniques, materials, and knowledge that we have lost, and some that we still cannot fully replicate today. This is the story of the most sophisticated building project in the ancient world and why it remains beyond us. Welcome back to the hidden archive where history hides its secrets. Today we are going to ancient Rome to understand why the building that defined an empire for 500 years is also the building that modern engineering cannot fully explain or replicate. Subscribe if you're new. A new mystery every week. Before we get to why we cannot rebuild it, we need to understand what we would be trying to rebuild. The Colosseum, officially known as the Flavian Amphitheater, was completed in 80 AD under Emperor Titus. It took approximately 10 years to build, employed an estimated 100,000 workers including prisoners of war, and used a staggering quantity of materials. The numbers are extraordinary. The Colosseum used approximately 100,000 cubic meters of travertine limestone, enough to fill 40 Olympic swimming pools. It used 300 tons of iron clamps to hold the stone together without any mortar between many of the blocks. It used volcanic rock called tuff, brick, and a concrete mixture that was unique to Roman engineering. The structure is 188 meters long, 156 meters wide, and originally 48 meters tall, roughly the height of a 16-story building. It could hold between 50,000 and 80,000 spectators, more than many modern football stadiums. It was completed and opened in 80 AD. It has been standing for nearly 2,000 years. And the most remarkable thing about it is not its size. It is the fact that despite earthquakes, stone robbers, fires, and 2,000 years of weathering, approximately 2/3 of the original structure is still standing today. Here is the first reason we cannot rebuild the Colosseum, and it is the most important. The Romans invented a concrete that is, in many measurable ways, stronger than anything we make today. Modern concrete, the stuff used in every building, bridge, and road in the world, has a critical weakness. It cracks over time. Water gets in, the steel reinforcements inside rust and expand, cracking the concrete further. Modern concrete structures have a typical lifespan of 50 to 100 years before they require significant repair. Roman concrete, opus cementitium, has been standing for 2,000 years and in many cases is still getting stronger. The reason was discovered by scientists at the University of California, Berkeley in 2017, and the answer shocked the engineering world. Roman concrete was made using a specific combination of volcanic ash from the region of Pozzuoli near Naples called pozzolanic ash mixed with seawater and lime. This combination creates a chemical reaction that produces a rare mineral called tobermorite, which forms long interlocking crystals that actually reinforce the concrete from within. And here is the extraordinary part. When seawater penetrates Roman concrete, rather than weakening it the way it weakens modern concrete, it triggers the growth of more tobermorite crystals. The seawater makes Roman concrete stronger over time. Modern engineers have been studying this for years. We can approximately recreate the formula. But the specific volcanic ash from the Pozzuoli region, the exact material the Romans used, is no longer available in sufficient quantities. And without it, we cannot fully replicate the chemistry. The Romans stumbled onto one of the greatest engineering materials in history. And we lost it? The travertine limestone that forms the bulk of the Colosseum's exterior came from quarries near Tivoli, approximately 20 kilometers from Rome. These quarries are still active today. So why is this a problem? Because of scale. The Colosseum used approximately 100,000 cubic meters of travertine. At modern quarrying rates, extracting that volume of stone would take years and cost hundreds of millions of dollars. But the transportation is where the real challenge begins. The Romans transported the stone from Tivoli to Rome along a specially constructed road, using ox-drawn carts. Historians estimate this transport alone required millions of man-hours and thousands of animals over the construction period. Today, we would use trucks. But here is the problem: the Colosseum is in the center of one of the most heavily trafficked cities in Europe. The surrounding streets cannot support the kind of heavy vehicle movements that would be required to bring 100,000 cubic meters of limestone into the city center. The logistics of simply getting the materials to the site would be an engineering challenge on a scale that modern urban planners have no good answer for. Here is something most people don't know about the Colosseum. Many of the travertine blocks are not held together with mortar. They are held together with iron clamps, approximately 300 tons of iron clamps running through channels cut into the stone. This system is actually more sophisticated than mortar. The iron clamps allow the structure to flex slightly during earthquakes, absorbing the energy rather than cracking. It is why the Colosseum has survived multiple significant earthquakes while other ancient structures have collapsed. But here is the problem with rebuilding this system. The iron clamps require perfectly cut channels in the stone blocks, channels that align precisely with the clamps across multiple blocks stacked on top of each other. This requires extraordinary precision in the cutting and placement of each block. Ancient Roman stonemasons spent their entire careers developing the skills to cut limestone to this precision. Modern stonemasons with these specific skills are extremely rare, and training them would take years. The Colosseum was built by an estimated 100,000 workers over approximately 10 years. These included architects, engineers, stonemasons, concrete mixers, iron workers, carpenters, and an enormous support workforce. Many were prisoners of war, captured Jewish slaves following the destruction of Jerusalem in 70 AD by Emperor Titus's father Vespasian. Today, we obviously would not use slave labor. But the scale of skilled workforce required is still staggering. Modern construction of a comparable structure uses sophisticated machinery that can do the work of dozens of manual laborers. But many of the specific skills involved in Colosseum-style construction, hand-cutting travertine, mixing Roman concrete, fitting iron clamps into precisely chiseled channels, cannot be replaced by machinery. Engineers estimate that a modern attempt to rebuild the Colosseum would require a skilled workforce of 10,000 to 15,000 people, not 100,000, because of machinery, but would still take an estimated 7 to 10 years. And the cost studies suggest a modern rebuild would cost between $300 million and $1 billion. For comparison, the original Colosseum was largely funded by the loot taken from the destruction of Jerusalem, an incalculable sum in today's money. Here is what makes the Colosseum truly extraordinary and what separates it from any modern attempt to rebuild it. The Romans did not just build a stadium. They built one of the most sophisticated crowd management systems ever designed. The Colosseum had 80 entrances. It could empty all 50,000 to 80,000 spectators in approximately 15 minutes, faster than most modern stadiums can evacuate today. This was achieved through a system of vomitoria, the passageways and staircases that distributed crowd flow throughout the building, designed with such mathematical precision that the crowd movement was essentially self-organizing. Modern engineers have studied the Colosseum's crowd flow system and found that it uses principles that were not formally described in architecture and engineering until the 20th century. The Romans discovered these principles empirically through observation and refinement without any of the mathematical tools we use today. Beneath the arena floor, the Romans built an elaborate underground system, the hypogeum, containing cages for animals, lifts to bring gladiators and wild beasts up through trapdoors in the arena floor, and a sophisticated drainage system. The hypogeum used 28 elevator shafts operated by counterweight mechanisms that could simultaneously deliver 28 wild animals to the arena floor in dramatic fashion. We do not fully understand how these elevators worked. We can see the shafts. We can see the counterweight mechanisms. But the exact engineering of how they operated, how they were synchronized, remains a subject of active research. Here is the twist that changes the entire story. The Colosseum we see today is not the original Colosseum. Over the centuries, approximately 2/3 of the original building stone was removed, quarried, and used as building material for churches, palaces, and other structures across Rome. The marble seating, the stucco, the decorative bronze fixtures all gone. The iron clamps were pried out of the stone, leaving the distinctive holes you see in the travertine today, and melted down for weapons. What survives is the structural skeleton, the bare bones of what was once one of the most lavishly decorated buildings in the ancient world. If we could see the original Colosseum with its marble seating, its painted stucco exterior, its bronze decorations, its wooden arena floor painted to look like sand, its massive awning system covering the entire seating area, it would look nothing like the ruin we see today. The building we cannot rebuild is actually the ruin. The original, the complete, decorated, fully operational Colosseum is even further beyond our reach. The Colosseum has stood for nearly 2,000 years. It has survived earthquakes, fires, wars, stone robbers, and the collapse of the civilization that built it. And the reason it has survived: the volcanic concrete that gets stronger with age, the iron clamp system that absorbs earthquake energy, the mathematically precise crowd flow design are the same reasons we cannot rebuild it. Because we have lost the knowledge. Not all of it, but enough. The Romans were not more intelligent than modern engineers. They did not have more advanced technology. But they had something we have lost: centuries of accumulated practical knowledge, refined by generations of builders who learned from each other, passed down in ways that did not survive the fall of Rome. A building that took 10 years to build has outlasted the civilization that built it by 1,500 years. And it will probably outlast us too. Subscribe to the Hidden Archive, a new mystery, every week, where history hides its secrets. End.